Hello everyone, my name is Anton, and 1 week ago I did a video about OG4D camera. And I promised that in 1 week I will release a next video about stereo depth estimation, neural stereo depth estimation that you can run on this camera. This video will be a little bit more general. What new did Luxonis with the stereo depth estimation camera and how to use this algorithm and how to work with it. So let's start. Let's start with the question why stereo depth estimation on NPU is a complex task. As you already know, and if you didn't know, please check my previous video about this camera. It's a lot of information about NPU on this camera, CPU, and so on. So, this specific camera has pretty powerful NPU inside. 48 TOPS of computational power. But NPU, it's pretty bad device to infer your stereo depth estimation neural network. Why? There are a few approaches how you can create the stereo depth estimation. First of them, complex 3D convolutions. A lot of stereo depth estimation use such neural networks. So if you use this complex for the 3D convolution, you work with 4D dimensions, and in these dimensions, a lot of NPU, they just don't have enough primitives to work on. The second approach is some complex neural networks when you use some shift or correlation operation, where you just in dimension of features, you do initial estimation, then on the next level you shift this with different distance, then depending on output of this level, on the next level, you're doing this again. And it's actually pretty complex methodology how to work on NPU. And of course, there are a lot of other problems because, for example, with foundational depth stereo, the complexity is because such neural networks are super big and you just can't run them on this NPU because it's too limited amount of memory. So, and previously there was no neural network that could work with such NPUs. What Luxonis did here, actually, I don't know. I have a few hypotheses. I didn't find any network architecture inside. So for me, it's also a pretty interesting question. My two main hypotheses. First, it's just use a distillation on the big data set where initial images were shot by foundational depths. And the second, it's they are using the stereo depth estimation plus original image as a feed for the neural network. So you just moving the stereo depth estimation with classical algorithm to the same image. You're trying to estimate depth in each point. I don't know, maybe they have some different algorithms, but in my opinion, it's to approach how to solve this problem with NPU utilization. Somehow they solved it here. After I recorded this video, Luxonis released the article about the stereo depth algorithm, and actually my first hypothesis was pretty close, but they didn't highlight what's the network architecture and what was the training dataset, but at least one of the main ideas why it's performed well, it's because a pretty nice distillation from the big data set which was shot specifically with this camera, and this definitely should have a big effect of the accuracy of the network. They have here three different algorithms. Classical stereo depth estimation without any neural network, stereo depth with their own neural network, which is neural stereo depth, and also you can use here some SRE stereo net. It's not working great in my opinion. We will go a little bit after, but here you saw all three videos with all three stereo depth estimations, and you can actually compare on the same scenes. With here you can easily find that yes, it's like have all typical problems, like on dark objects it's a little bit noisy, a lot of irregularities in time where everything is drifting. Of course, some problems with complex texture, but you definitely can see that this narrow stereo depth estimation, it's improving existing level completely. So let's talk about this interesting feature with SRE stereo depth estimation. As you can see, here image is not stable and the quality is not excellent. But if you will run the same stereo depth pair through neural network, like through original neural network, quality is much better. So why is it? I think it's the same problem with stereo with this NPU, because I saw similar artifacts, for example, on Intel NPU and so on. So this SRE stereo, yes, probably you can run, but accuracy will be a little bit lower than the version without this NPU inference. So in my opinion, the best stereo depth estimation neural network here for this device is the narrow stereo depth. I don't know which algorithm is behind, but let's look on a few advantages and disadvantages of algorithms that I use. The first of all, it's they trying to make here metric stereo. What is metric stereo? Where you have some probability for each point. And for example, if you don't have the real measurement for some point, you just trying to exclude this. And you can see this in these shadows. All these shadows, they are created by uncertainty, because if you can see this region only with one camera, then you can't estimate with enough probability with the second camera. How, like, classical stereo depth estimation neural network work in such situation? For example, the same SRE stereo or foundation stereo, they just made some assumption. And for example, if here in this region there will be some object, of course they will predict incorrectly. From their perspective, they're trying to fill each point of the space, but Luxonis is not trying to fill the whole point of space. And it's pretty important difference. In my opinion, for different algorithms and different situation, different neural network actually are preferable. So in my opinion, if they will do a switch where you can just switch between like original, this metric estimation and estimation for roll point, it would be great. But for now, they have only one option where you can run this whole stereo. And returning again to their article that they publish, they actually treating this as a plus, because again, in some situation, it's really important thing which no of the modern depth estimation neural network can do. But for example, if you're working with robotics and you need to grasp some object, it's better to have at least some guess about what is behind this object and how to grab it. So yes, it's great to have such algorithm, but maybe in some situation it's better to have different algorithm for the same object. Also, with this neural stereo depths, they actually have a few different network with different like resolution, frames per second, and so on. In my experiments here, I used the biggest one, and it's actually working quite nice. Also, in my opinion, I need to show a few different images. It's the same camera. Actually, it's pretty nice stereo depth estimation camera, but where I use some existing stereo depth estimation network that I run on GPU. For example, here it's like the maximum theoretical accuracy with the best model up to date, it's foundational stereo. And Of course, it's much better, but to calculate such image, you need like more than 10 seconds on pretty good GPU. So, of course, it's like theoretical maximum, but here it's what we can get in real time. In my opinion, it's a big step with already existing previous generation of cameras. Of course, it's a little bit lower than some algorithms that calculating on GPU, and you can find even some stereo cameras that are oriented on GPU today, but in my opinion, it's much better for a lot of tasks if you have this NPU directly in your device, like here device, because it's just fully workable device. It can be connected to LAN, and then you can use all this data on the other part of the world. You don't need any GPU here. It has pretty nice cooling. You don't need to think about all this stuff. These devices already have everything what it needs. But yes, in my opinion, in some situation when you need like the maximum possible quality, maybe it's better to install GPU locally and just consume your stereo depths on this GPU and calculate this. But it's like, in my opinion, it's just different type of device. And also article was released. I checked this article and maybe I want to append a few things that I didn't mention in the video. First of all, yes, they have additional output of this stereo depth estimation, like one of them with confidence, one with edge. I don't know how to use this edge estimation, but for example, with confidence, yes, you can manipulate this a little bit. And for example, you can try to restore some objects that is hidden because information is uncertain. For example, on this my image, you can check that some information on my wall is uncertain and on the table. But when I experimented with this, actually it wasn't like a super big difference in this. Also, I didn't mention that they will have a bigger model. Pretty nice and interesting to check. And also they mentioned here it's like some additional limitation for calculation, but actually it's not a big, in my opinion, limitation when you calculating this on device. Otherwise, you need to transfer these images on some host where you need to run your neural network. It also will spend some time to encoding, decoding, inferencing. So in my opinion, it's not a bad latency actually. So all other stuff I think I mentioned somehow. And here they showing why it's important to have stereo. But actually, if you will run some stereo depth estimation neural network, usually they also working like this in such condition. But of course, sometimes you can trick on some edge cases with some neural networks. So all other stuff I think I mentioned in my video. Here's what I wanted to append about the stereo depth estimation algorithm, how it's working, and everything around. Thank you for watching. Bye.